Solution. From the diagram, we are given that from the question, the galvanometer is having 50 ohms, and which is a deflection of 1 milliampere, is to be then the current that is passing through the circuit is 5 ampere. So we are asked to calculate the resistance of the resistor. Then looking at this diagram, we have that the current of 5 ampere is passing through a galvanometer having 50 ohm resistors, and the resistor of the shunt is not known. We are asked to get the resistance of the shunt. So you know that V is equals to IR, that is voltage is equals to IR. Then substituting the values and equating it together, we have that 4.99 times shunt is equals to 50, which is what is giving the galvanometer reading, and the current times current, which is 0.001. Therefore, making the shunt the subject of the formula, we now have 50 times 0.001 all over 9.99, which will give us 0.01 ohms. B, R is equals to rho L over A. Making L the subject of the formula, we now have RA over rho, which is equals to 0.01 times 4 times 10 raised to power minus 4 all over 2 times 10 raised to power minus 6, which will give us 2.0 cm. Example 3. Calculate the resistivity of the wire of length 2 meter and a cross-sectional area 0.004 cm cube if its resistance is 3 ohms. Solution. Resistivity rho is equals to R, capital R, resistance times area, capital A, all over length, capital L, which is equals to, we are given that the resistance is 3 times the area is 0.04 cm cube all over our length is 2 meters. To convert to cm, we now times by 100 to give us 2 times 100, which will now give us our resistivity as 0.6 ohms per cm. Example 4. An electric heating element made from nichrome wire of cross-sectional area 0.5 mm square has a resistance of 220 ohms. Calculate the length of wire required if the resistivity of the nichrome is 5.5 times 10 raised to power minus 7 ohms meter. Solution. Area capital A is equals to 0.5 mm squared, which equals to 0.5 times 10 raised to power minus 3 squared meter squared, which equals to 0.50 times 10 raised to power minus 6 meter squared. From capital R equals to rho L over A. L is equals to capital R times capital A all over rho, which equals to 2.20 times 0.50 times 10 raised to power minus 6 all over 5.5 times 10 raised to power minus 7, which will give us 2 meters. Conductivity. Conductivity delta is the inverse of resistivity. That is, conductivity is equals to 1 over resistivity, which is equals to conductivity. The unit is per ohms per meter. Electrical measurement. 1. Measurement of potential difference, capital V, using potentiometer. Since the wire is of uniform cross section, the resistance per unit length is constant. That is, capital R is proportional to I. For a constant current I, capital V equals to IR, which equals to KI. 2. Comparing two low resistance using potentiometer. Figure 427 shows a diagram of comparing the resistance using potentiometer. If a balance L1 is obtained with X connected to A and Y to B, and a balance L2 when X is connected to B and Y to C, then VAB over VBC equals to I1 over I2, which equals to R1 over R2. Comparison of EMF using potentiometer. Figure 428 compares EMF of cells. At a balance point, the EMF capital E is proportional to the balance length L. Therefore, if a cell of EMF E1 gives a balance length L1 and a cell of EMF E2 gives a balance length L2, since E1 is equal to KL1 and E2 is equal to KL2, we have that E1 over E2 equals to I1 over I2. Example 1. In the potentiometer circuit above, the cell E1 has EMF of 0.8 volts and the balance length for cell E1 and E2 are 40 cm and 60 cm respectively. What is the EMF of the cell E2? Solution. E1 over E2 equals to L1 over L2. 0.8 over E2 is equals to 40 over 60. Making E2 the subject of the formula, we now have 0.8 times 60 all over 4, which equals to 1.2 volts. For measurement of resistance, Wheatstone bridge. The most convenient and accurate way of measuring resistance over a range of widely different values is given by means of Wheatstone bridge. Figure 4.29 Wheatstone bridge. It consists of four resistors R1, R2, R3 and R4 connected as shown above. When current from battery is passed and one of the resistors is varied, a balance point may be reached. This means that no current flows through the galvanometer. It follows that R1 over R2 equals R3 over R4. Example 2. What is the value of R4 in figure 4.29 when G shows no deflection in the circuit shown above? Solution. When G shows no deflection, R1 over R2 is equals to R3 over R4. 40 over 60 is equals to 30 over R4. R4 is equals to 30 times 60 all over 40, which is equals to 45 ohms.